We have studied lines, segments, angles, etc. in the previous class. We measure an angle in degrees. Suppose an angle ABC has a measurement of 40 degrees, then we write it as measure angle ABC equal to 40 degrees. We will first learn to construct the angle bisector of angle ABC with the help of a straight edge and a compass. Bisector of an angle. Take some distance from the vertex B with the help of a compass and draw an arc on the ray BA. Name the point as A1. Keeping the distance same from the vertex B, draw an arc on the ray BC as well. Name the point as C1. Keeping the distance same from the point A1, draw an arc in the interior of angle ABC. Now, draw one more arc from the point C1 in the interior of angle ABC that cuts the earlier arc by keeping the distance same using the compass. The point of intersection of these two arcs is named as M. Finally, draw a ray BM from the point B that passes through the point M. Ray BM is called as an angle bisector of angle ABC. The bisector of an angle divides an angle into two equal parts. Any point on the bisector of an angle lies at an equal distance from both the arms of the angle. The concept of an angle bisector can be easily understood via paper folds. Construction of the bisector of an angle through paper folding. Let's draw a 60-degree angle on the given piece of paper. Cut the paper along the arms of the angle carefully. You can see that there are infinitely many points in the interiors of this angle. Now, fold the paper in such a way that both the arms of the angle coincide with each other. The fold thus formed passes through the vertex of the angle. Unfold the paper to see the crease line which forms the angle bisector of the given angle. Property of the angle bisectors of a triangle. Let us draw a random triangle, say triangle PQR. As we have already learned, draw the bisectors of all its angles using a straight edge and compass. All the three angle bisectors pass through a single point, that is, they are concurrent. The point of concurrence is termed as the incenter and is denoted by the letter I. In the triangle PQR, the sides PQ, QR and PR lie at an equal distance from the point I. If you draw the perpendiculars IA, IB and IC from the point I on the sides PQ, QR and PR respectively, then you get the distances of these sides from the incenter I in the same order. Measure the lengths of all the three perpendiculars drawn inside the triangle. What do you notice? All the three perpendiculars are equal in length. That is, IA is equal to IB is equal to IC. A little fun. Fix the distance IA and draw a circle keeping I as its center with the help of a compass. The circle touches all three sides of the triangle. It is referred to as the incircle. Such constructions hold significant place in the field of art and design. Construction of angle bisectors of a triangle with the help of computer. Let us draw a random triangle, say triangle PQR. Look at the angle bisectors passing through the vertices P, Q and R of triangle PQR. We get the point of concurrence I of all three angle bisectors. Property of the angle bisectors of a triangle through paper folding. Let us draw triangle PQR on a paper. Use a paper fold to place one side of the triangle onto the other. Unfold to get the crease line passing through the corresponding vertex which forms the required angle bisector. Similarly, obtain the angle bisectors of all three angles of triangle PQR. All the three angle bisectors pass through a single point, that is, they are concurrent. The point of concurrence is termed as the incenter and is denoted by the letter I. Perpendicular bisector of a line segment. Bisector means a ray that divides into two equal parts. We observe such bisectors all around us. For instance, the road divider. It is so constructed that it should be at an equal distance from both sides of the road. Look at the rope and see how it is divided into two equal parts. Construction of the perpendicular bisector of a line segment. Let us first draw a line segment, say PQ. To draw the perpendicular bisector of segment PQ, take up approximately more than half the distance of segment PQ with the help of compass. Placing the point of the compass on Q, draw arcs on both sides of segment PQ. Keeping the distance same, place the point of the compass on P and again draw arcs on both sides of segment PQ that intersect the previous arcs. Join the points of intersection of these arcs by a line segment CD. Name the point of intersection of segment PQ and segment CD as M. To cross-check whether segment CD is actually a perpendicular bisector or not, measure angle CMS. Measure angle CMS is equal to 90 degrees. Measure the lengths of segment PM and segment SM. What do you notice? Length PM is equal to length SM. Construction of the perpendicular bisector of a line segment through paper folding. Let us first draw a line segment PS having length 4 cm on a piece of paper. Fold the paper to match the points P and S. Fix the fold using your fingers. Unfold the paper to get the fixed crease line as the perpendicular bisector of segment PS. Perpendicular bisectors of the sides of a triangle. Draw a triangle XYZ with the help of a straight edge. The point of concurrence is called as circumcenter and denoted by C. Measure the distance of each vertex of triangle XYZ from the circumcenter C. What do you observe? Cx is equal to Cy is equal to Cz. The vertices of a triangle are all equally spaced from its circumcenter. Circumcenter of an acute angled triangle lies in the interior of the triangle. Circumcenter of a right angled triangle lies on the side of the triangle. Circumcenter of an obtuse angled triangle lies in the exterior of the triangle. A little fun. Fix the distance Cx and draw a circle keeping C as its center with the help of a compass. The circle passes through all three vertices of the triangle. It is referred to as the circumcircle. Such constructions hold significant place in the field of art and design. Perpendicular bisectors of a triangle through paper folding. Draw a triangle XYZ with the help of a straight edge on a piece of paper. Match any two of its vertices at a time and get the perpendicular bisectors of all three sides. We will get the point of concurrence C of the all three perpendicular bisectors of the sides of the triangle. Construction of the perpendicular bisectors of the sides of a triangle with the help of computer. Draw a triangle XYZ. Draw a perpendicular line passing through the midpoint of a side of the triangle with the help of computer. Repeat the procedure for all three sides. The perpendicular bisectors of all three sides intersect at a single point. GPS uses this structure or construction to find places lying at an equal distance from a particular location. Challenge. Does the property of concurrence of the angle bisector of a triangle and also its property of incircle apply to a square and a rectangle as well? Does the property of concurrence of the perpendicular bisectors of the sides of a triangle and also its property of circumcircle apply to a square and a rectangle as well? Try to understand by drawing figures.